Okay, today we're going to talk about reference triangles. Yesterday was right triangles. Now we're going to talk about reference. Reference triangles are still right triangles. They're just kind of a subcategory of right triangles. So reference triangles are drawn on a coordinate axis, or basically on graph paper. For this particular assignment, I don't care if you want to sketch graph paper on your homework, if you want to use the digital graph paper that we were using first semester, doesn't matter to me for this particular homework. All right, but reference triangles are superimposed onto a grid with an origin. So everything will have an x-axis, a y-axis, and origin, and you'll draw your triangle on that. That's what makes it a reference triangle. There are 3 guidelines when you draw a reference triangle, and they are this. The hypotenuse always connects the origin to another point out in one of the quadrants. All right, so for example, if you had 2 coordinate grids like this and you were trying to draw what might be called a reference triangle, this would not be a reference triangle. Okay, I've drawn it in yellow because the hypotenuse doesn't connect the origin to a point. It's just connecting 2 places on the axis to each other. That is not a reference triangle. A reference triangle has to connect the origin to some point out in the quadrant. So this, oops. Okay, this one is not a reference angle, but the other one is a reference triangle. Okay, that's the first guideline. Guideline 2, no matter what quadrant you're in, okay, so no matter the quadrant, side B is always on the x-axis. So first you got to follow step 1, where the hypotenuse would connect the origin, and then no matter what quadrant you're in, side B would always be on the x-axis. So for example, say you were in quadrant 3, and you drew your hypotenuse out to a point out in the quadrant like that. Then how do you draw the rest of the triangle? Okay, well, you wouldn't go like this, because if you did that, side B is now floating out in quadrant 3 down there, right here, and that's not where side B needs to be. You need to draw it in such a way that side B is sitting on the x-axis. So it would not look like that. Okay, rather, it would look like this, so that side B was sitting on the x-axis. All right, so guideline 1, hypotenuse has to connect the origin to a point out in the quadrant. 2, side B needs to be on the x-axis. And then there's a third guideline. The angle, which will be a Greek letter, okay, it could be alpha, it could be theta, it could be phi, it could be gamma. The Greek letters are used for angles, but the angle is placed closest to the origin. Okay, the angle is placed closest to the origin. So again, if you're looking like this and we've met our guidelines and we've drawn an angle like this and everything is in the right place, okay, where do you put the Greek letter? So you are not going to put the Greek letter down here in that corner because it's not the corner closest to the origin. You're going to always put your Greek letter that's indicating the angle in the one that is closest to the origin. Okay, any questions so far about drawing reference? Yep. So what we're going to do is just practice drawing a couple of these reference triangles. If I give you a point, and then I want you to create the reference triangle that would be drawn from that point. All right, so here we go. Here's your first example point. Create a reference triangle that goes through point P, and point P is sitting at 12, -5. All right, so what you're going to do is if you have graph paper, you'll be using graph paper. Otherwise, if you're just sketching, like I'm sketching, that would be okay too. So first you want to position point P to be at 12, -5. What quadrant will that end up in? Fourth quadrant, okay? So out to 12 here and down to -5. So point P is sitting about right there. Now you want to create your reference triangle. So you want to draw the hypotenuse first. So you'll start at that point and go back to connect to the origin. So that'll be your hypotenuse. Label that C. Then side B needs to be on the x-axis. So we'll create side B along there, which would leave your final side A down that way. And then you want to place your Greek letter that you've chosen to represent the angle. We have lots of Greek letters to choose from. The most common is theta, but you can use alpha. You could use gamma. I can teach you. There's different, oops, that was not, that's one of my favorites. Okay, that's gamma. You can do mu, which is like a, I don't know, like a U kind of with a, okay, there's a lot, you can do phi, which is this one, whatever you choose. Okay, but we'll stick with the one we talked about yesterday, so theta. So that's how you would draw that, and then you would label, okay, how long the different sides are. So between A, B, and C, which ones do you know the lengths of right now? Okay, what's B? What's A? -5. Okay, because it's in quadrant 2 or quadrant 4, so it's going down there. Couldn't you figure out C? Okay, this is going to be using the Pythagorean theorem. And if you're on your toes, you recognize that 5 and 12 are part of the Pythagorean triple, and you can save yourself the work. Okay, so C is always going to be 13. Those numbers always go together. Okay, there's some famous Pythagorean triples, and if you know those, it's going to save you the work. All right, the ones that are the most common are going to be 3, 4, 5, 6, 8, 10, which is the double of 3, 4, 5. Just double them all. In fact, you could triple them and create all kinds of ones, but 3, 4, 5 is the base one. And then 5, 12, 13. Those are the most common Pythagorean triples. If you happen to recognize them, it saves you the work of having to figure out the Pythagorean theorem. The longer one is always the hypotenuse. So in other words, if you had 3 and 5 listed as your A and B, it would not be 4 for C. That doesn't work that way because now 4 is too short. The last one always would need to be the longest one. So that is not a Pythagorean triple. All right, good. So let's do one more, just practicing creating a Pythagorean a reference triangle. All right, so this time the point we're going to create is going to be -rad5, -rad2. What quadrant will that drop into?
Third.
Third. Why, Danny?
This is both negative.
Both of them are negatives. That's going to drop me into quadrant 2. So I'll either sketch or use graph paper. -rad5 is about -2.4-ish. So you're doing an estimate of your best position on that. Okay, -2, and then -rad2 is about -1.7. And so you'll do your best estimate of that, and we'll put our P down there. So to create this reference triangle, go back to the origin. That's your value, that's your hypotenuse. Angle B should be along the x-axis, or side B should be along the x-axis, which means side A is dropping down into the third quadrant there. And then you'll place your angle, okay, the one that's closest to the origin. So I'll use gamma this time. Okay, and that's my angle. And then again, you can label the values. We know that B is the value of -rad5, and A is the value of -rad2. Now, just because A and B are both negative doesn't mean that C is going to be negative. The hypotenuse, no matter what direction it goes, is always a positive number. If you are in a physics class or you know about vectors, vectors are always positive, and so we're going to have, well, the magnitude of the vector is always positive. I shouldn't say that it's always positive. But our hypotenuse is always going to be positive. So we can use the Pythagorean theorem to figure that out. So we're going to use a squared plus b squared equals c squared. When you square numbers that are negative, please be super careful that you use parentheses. It is negative rad 2 squared. And then it is parentheses negative rad 5 squared when you're figuring that out. If you don't use your parentheses and you're going to verify that on your calculator, you will get negative numbers instead of positive. Negative rad 2 squared, which means multiplying it by itself, is a positive number. And negative rad 5 squared multiplied by itself is a positive number. So I get 2 plus 5, so I get 7. And so C is going to be the positive square root of 7. Okay, any questions so far about reference triangles? Okay, from a reference triangle, you can get the 6 SOHCAHTOA things we learned yesterday. So let's continue this problem. We won't go back to the other one, but let's continue this one and do the 6 SOHCAHTOA values, the SOHCAHTOA and then cosecant, secant, and cotangent from that particular picture. And so we would have sine of, and I called it gamma this time, sine of gamma, cosine of gamma, tan of gamma. And so you should be able to get the opposite and the adjacent values from the picture now that you've created. So the sine of gamma should be the opposite over the hypotenuse, which is negative rad 2 over rad 7. The negative isn't really part of either the numerator or the denominator. The negative kind of floats out in the front and is the whole thing is negative. One other thing that is a common misconception is those radicals don't cancel out. So just because you have a radical of 2 over a radical of 7 does not mean that it reduces to just 2 over 7. The radicals do not cancel each other out. But once we have the sine, opposite over hypotenuse, we can also automatically give ourselves the cosecant of gamma. Again, and the negative just sort of stays out in front. It's not attached to the numerator or the denominator, so it would be negative rad 7 over rad 2. The cosine would be the adjacent, so that would be negative rad 5 over rad 7. And so then secant would be negative rad 7 over rad 5. The final part would be tangent, so TOA, so opposite over adjacent. So this time I've got negative rad 2, and I also have a second negative over the rad 5. This is the only time that you do reduce. Negatives reduce each other. Radicals don't, but negatives do. And so when you have a negative, 2 negatives making a positive, then you're going to want to have that be the positive rad 2 over positive rad 5. And then cotangent would be, of gamma, would be rad 5 over rad 2. Any questions or points of clarification on what we've done so far? Sometimes you'll see a picture that looks like this. You might see a drawing that sticks a point out here, and then they have something that looks like this, and they say theta, like that. Okay, that theta is not part of your reference triangle. Because first of all, it's not in a triangle, and it's not closest to the origin. So when you create your reference triangle from that picture, so hypotenuse, base, you are going to put your own Greek letter down here. You can call it alpha, or you can call it phi, or any of the other delta, okay? But it's not going to be the theta on the outside, because that's not part of the requirements of being in the reference triangle. Okay, the set of examples are, we're going to ratchet it up a little bit. This is a higher order thinking. Okay, this is taking something that's abstract and kind of wrapping your mind around it and sort of trying to unwrap the riddle that comes from it. So we'll work on this together and see what we can do. It's going to look something like this. All right, find cosine theta and tan theta if, and then you're going to be given some clues. So find cosine theta, which is going to be adjacent over hypotenuse, and tan theta, which will be opposite over adjacent. Find if, and then we're going to be given two pieces of information. Number one, tan theta less than 0. If something is less than 0, what sign does it have? A negative. So this is basically telling us it's going to have a negative sign. Okay, so that's the first clue we get. Clue 2, sine theta is 3/7. All right, so those are our clues. We have to use those clues to figure out what cosine theta and tan theta are. And we're going to use reference triangles to do it. So draw yourself a grid. If tan theta is supposed to have a negative sign, something has to be negative in this problem. All right, if tan theta has a negative sign, then I have to use a quadrant where there are things that are negative. Okay, so what quadrants don't have anything negative in them? It's the only quadrant that doesn't have any negatives. 1. All right, so I absolutely will not be using quadrant 1. So eliminate that right away. So could I use one of the other quadrants? And the answer is sure. Okay, so could it be a reference angle in quadrant 4, or could it be a reference angle in quadrant 2, or where could my reference angles be? So let's start with, well, we'll start with 4. Could be 4 because 4 has some negative stuff in it. So draw a possible arbitrary reference angle. So when I say arbitrary, that means you don't have any numbers labeled on it yet. We will put some numbers on. Try to clean that up a little bit. Okay, if we put our theta where it's supposed to be, and we know that sine of theta is 3/7, what does that tell me about where the 3 is supposed to be positioned? And what does it tell me about where the 7 is supposed to be positioned? Okay, if sine of theta is 3/7, remember SOHCAHTOA from yesterday, where is the 3 supposed to be relative to theta? On the opposite, okay? All right, and where's the 7 supposed to be positioned? Okay, does that fit with that quadrant? Can I have a 7 and a 3 in the positions that they're in? And the answer is no, but I want to know why. What's the problem? The 3 should be negative. Okay? So that means that this triangle is not the right reference triangle. So I'm just going to ditch it, get rid of it. It's not the right one. All right, well, let me try this quadrant because it has negative stuff in it. Okay, if I draw a reference triangle in that one, okay, and I put theta in the right position, if I put 3 and 7, 3 is opposite and 7 is hypotenuse, does that at least fit so far? Okay, that's good because that side could be positive in that triangle and the 7 could be positive. Wait, what about the bottom? What about the missing value across the bottom? Can you do the mental math on that for Pythagorean theorem and figure out what that value is supposed to be? Okay, a squared plus b squared equals c squared. What do we get? I thought I heard somebody say it.
2 rad 3.
Not 2 rad 3. Not 2 rad 10.
40.
Let's try negative 2 rad 10. Okay? Because it's on that side of the origin. And when we graph things, that side of the origin needs to be negative. So rad 40, okay, that's 7 squared is 49, 3 squared is 9. Subtract them, you get 40. So it's rad 40, but it's negative 2 rad 10. Okay, how am I doing? Have I met all of my criteria so far? Okay, let's check criteria 1. Will the tangent have a negative sign? Okay, tangent is TOA. If I create TOA, will it have a negative sign? Yeah. The 3 and the negative 2 rad 10. One's positive, one's negative. It'll be a negative sign. And the sign is 3/7. So I have met the requirements. Now I have to answer the question, which is find what cosine and tangent are for this picture. And that will answer the question. So what is cosine theta for this particular picture? This particular reference triangle. What is cosine? Okay, it's adjacent over hypotenuse. And the adjacent is negative 2 rad 10. And the hypotenuse was, what happened here? There we go, 7. So I just figured out the cosine. And the tangent, theta, based on this reference triangle picture, should be TOA. So it should be 3 over negative 2 rad 10. Okay, but I'm going to say again, in both of those options, the negative doesn't belong to either the numerator or the denominator. So it is best not to put it down there and not to put it up here. Okay, but put the negative out in front of both of them. Okay, it just kind of hovers out in front. Okay, we're going to try one more of those because these are hard. And you really got to wrap your mind around that. Okay, let's try another one. So same thing, let's find cosine and tangent using the following 2 clues. All right, so find cos theta and tan theta if the following things are true. Number 1, sine theta is greater than 0. So what does that tell you? It's positive, so it needs to have a positive sign. And requirement number 2, secant theta is equal to 3. Whoa. Secant theta is equal to 3. Well, what's secant theta paired with? Okay, cosine. So secant theta is equal to plane 3. What did cosine theta have to be? 1/3. We just answered half of our question because it said find cosine and I just did. All right, now I need to draw a reference triangle. And I need to have positive sign. So what should I eliminate right away? Quadrant 3. Everything's negative in quadrant 3. That is no good. All right, well, let's try quadrant 1. It's the most obvious. Okay, let's put 1 in there. I know that cosine is 1/3. Well, where does the 1 go? And where does the 3 go? Okay, cosine being 1/3, 1 should be assigned to the adjacent side, 3 should be assigned to the hypotenuse side. That leaves one side left. So doing some Pythagorean mental math, what is 3 squared? 9, and 1 squared is 1. So what's that left for my missing side? Rad 8, but not rad 8, 2 rad 2. If that's right, does the sign have a positive sign?
No.
If this is right, does the sign have a positive sign?
Yeah.
I think so, because what is sine? Opposite over hypotenuse. And what's the opposite? 2 rad 2, and the hypotenuse is 3. Everything's positive. We're good. So I know that this triangle is in the right place. So to answer the question now, I had to find cosine, which I already did, but I still have to find tangent. So I found cosine, but let's also find tangent for this particular reference triangle. And tangent for that reference triangle is TOA, and TOA would be 2 rad 2 over 1.